Hey guys, this looks like a fun one. It wants to know how long is this side, and it gives us a whole bunch of various measurements. If you want to try it on your own, pause it right now, because I'm going to solve it in 3, 2, 1. First, let's start with the green triangle. We know this angle 34 degrees, and we know this adjacent side. We don't know the hypotenuse. Let's call it little a. So the cosine of this 34 is going to be adjacent over hypotenuse, or in other words, 8 over a. We can put the cosine 34 over 1 and we can cross multiply. It'll give us cosine 34 times a equals 8 times 1. On the right hand side, 8 times 1 is just 8. And cosine 34 degrees is equal to 0.8290. From here, we can divide both sides by 0.8290, and that gives us a is equal to 9.658. And that's just approximate, and they only go 1 decimal point here, so let's just go 1 decimal point. So this whole side is 9.7 centimeters. Let's try to find this part of the yellow triangle. So the whole side is 9.7 centimeters, and this piece is 2.5 centimeters. That means this remaining portion will be equal to 7.2 centimeters. So let's update this side of the yellow triangle as 7.2 centimeters. And now we can move on to the yellow triangle. The hypotenuse of this triangle is made up of the 3.6 centimeters and the 7.2 centimeters. And after we add these together, it's 10.8 centimeters. And we don't know this adjacent side, let's call it little b. So once again, cosine of this 11 degrees is adjacent over hypotenuse. The adjacent is the b and the hypotenuse is 10.8. We can cross multiply, find the value of cosine 11, and then we end up with b is equal to 10.6. Let's update this b right here. And if this whole side is 10.6 and this piece is 2.1, that leaves for this last piece 8.5. And let's update this up here. Now we can focus on the red triangle. We don't need this right now, and let's bring in our 8.5. And 8.5 plus 2.9 gives us 11.4. So the hypotenuse of this triangle is 11.4. And we don't know this side, let's call it little c. And in this case, we can do Pythagorean theorem. It'll be 3.8 squared plus c squared equals 11.4 squared. And that ends up being 14.44 plus c squared equals 129.96. After we subtract 14.44 and square root both sides, we end up with c is equal to square root of 115.52. And that's approximately 10.75. Everything's been approximation, so let's just keep it as an equal sign. And we can label this side c as 10.8. Now let's bring back this 3.2, and this remaining portion is going to be 7.6. Up here, let's give ourselves some room to put this line in and label it 7.6. And now we're ready to do this blue triangle. We want this side, so let's call it little d. We have 42 degrees, this side d, and this side 7.6. Now we're going to do the tangent, which is opposite over adjacent. The opposite is this d, and the adjacent is 7.6. So we have tangent of 42 is equal to d over 7.6. After we cross multiply, we end up with d is equal to 7.6 tan 42. And tangent of 42 degrees is equal to approximately 0.9004. After we multiply this, we end up with d is equal to 6.84. So let's change this to 6.8. Next, we want this piece here. Let's call it g. In this triangle, we have the opposite and the hypotenuse. We're going to use sine. The opposite of the 37 is 6.8, and the hypotenuse of this triangle is g. After we cross multiply, we get sine 37g equals 6.8. And sine of 37 degrees is approximately 0.6018. After we divide both sides by 0.6108, we end up with g is equal to 11.37. So for this distance here, let's plug in 11.4. And now we have this total side length of this mustard triangle. It's going to be 4.3 plus 11.4, which is 15.7 centimeters. Now we can find this side of the mustard triangle. Let's call it little h. This will also be sine. Sine of 53 will be equal to the opposite h over the hypotenuse 15.7. And after we cross multiply and do all the math, we end up with h is equal to 12.54. So in the place of this h, let's plug in 12.5. And then if this whole side is 12.5 and this is 2.2, we can find out this side of this triangle. It's going to be this minus this, which is 10.3. Now let's find this side of this triangle. Let's label it j and let's do Pythagorean theorem. It's going to be 10.3 squared plus 1.7 squared equals j squared. And here's all the work here to find j is equal to 10.44. So in the place of this j, let's plug in 10.4 centimeters. Now let's find this side of this triangle and let's call it k. For the 21 degrees, this involves an adjacent and a hypotenuse. So we're going to use cosine. Cosine of 21 degrees is equal to the adjacent 10.4 over the hypotenuse k. After we cross multiply and do all the math, we end up with k is equal to 11.14. So let's update this side to be 11.1. And now we can find this entire side of this top triangle. It's going to be 1.7 plus 11.1, which is 12.8. And now we're ready to answer our question. How long is this side? Let's call it little l. This involves an opposite and a hypotenuse, so we're going to do sine again. So it'll be sine of 71 is equal to the opposite l over the hypotenuse 12.8. After we cross multiply, we end up with l is equal to 12.8 times sine of 71 degrees. Sine of 71 degrees is equal to 0.9455. And after we multiply this out, we end up with l is equal to 12.1. So we can make this 12.1 centimeters. And that is the answer to our question. Let's put a box around it. How exciting. And here's a preview of the next challenge problem. Hey guys, this looks like a fun one. We're given a giant square with two semicircles, each with a diameter of 4. And there's a circle inside of the square, and we need to find the area of the circle. And I'm pretty sure we're supposed to assume these 3 points are tangent points. If you want to try it on your own, pause it right now, because I'm going to solve it in 3, 2, 1. How exciting.